Hi guys, so we are going to continue on in chapter 5. We're going to be covering lesson 5.8, which is the last lesson of the chapter. We're going to be talking about coordinate proofs. All right, so let me present my screen and we'll get started. All right, so we are going to be looking at coordinate proofs. We're going to show how to prove, or I'm going to show you how to prove that a triangle is a right triangle, and we're going to be using a coordinate plane to do that. All right, and then I'm going to show you how to prove that triangle ABC is an isosceles right triangle. And then there's 2 practice problems that I'll leave for you guys to try on your own. So I only have these 2 problems to get through tonight with you. So it shouldn't, or whatever time you watch the video with you. It shouldn't be too long of a video. All right, so prove that triangle ABC is a right triangle, and its vertices are at A, 0, 1, B, 3, 4, and C, 5, 2. All right, so first thing I'm going to do, I'm going to make this coordinate grid bigger, just because for me, plotting the points with this pen is a little challenging when it's so small. So let's see if that'll work. All right, so I'm going to plot 0, 1. Where's my pen? There it is. All right, so 0, 1. This is point A. Point B is 4, 5. Point B. Here's A. And point C is at, what kind of grid? I'm sorry. Oh, I was sorry. I was on the wrong page in my notes. So I was looking at a different problem when I said B. Sorry, let's try that again. A is at 0, 1. B is at 3, 4. It's on the wrong page in my binder. And there's B. And C is at 5, 2. And there we go. All right. So there's our triangle. All right, so we want to prove that it is a right triangle. Well, what makes a triangle a right triangle? It has to have at least one right angle. All right, so triangle ABC is a right triangle if it has one right angle. All right. So how do you think we're going to prove whether or not this is a right triangle? Think about it for a second. What do you think I need to show or to show this right triangle? Should I take out like a compass and a protractor and like try to measure each of the angles? No, I'm not going to do it that way. All right. How are right angles formed? Right angles are formed when we have perpendicular lines, right? When 2 lines are perpendicular, we create a right angle. So perpendicular lines form a right angle. So we want to check for perpendicular lines by, how are we going to check for perpendicular lines? We're going to check we're going to calculate their slopes, because we know the slopes of perpendicular lines are opposite reciprocals. So check for perpendicular lines by calculating the slope of each line. Okay, so I'm going to have to find the slope of line AB. Then I'm going to find the slope of line BC. And I'm going to find the slope of line AC. Now, because we do have the graph, you could just count units, right? If you wanted to find the slope of line AB, I could just do rise over run, or you could plug into slope formula. AB, change in y, so 4 minus 1, change in y, 4 minus 1, over change in x, 3 minus 0. Those are minus signs. I know they look like little dots, but they're minuses. All right, so I have 3 over 3, which equals 1. Again, if I just do rise over run, it's up 1, 2, 3 over 1, 2, 3, 3 over 3, which equals 1. So the slope of BC, again, you can use slope formula or just count units. I have to fall 1, 2 units and run to the right 1, 2 units. So falling 2 is a -2, to the right 2, or to the right is a +2. So that's going to be a slope of -1. All right, and then for AC, from A to C, I'm going to rise 1 unit and run 1, 2, 3, 4, 5 units. So it's up 1 to the right 5. Okay, oh, that's a 5, and I ran out of room down there. So 1 out of 5. Okay, 1 over 5. So any opposite reciprocal slopes? We do. These are opposite reciprocals, right? You could write 1 as 1 over 1, and then the reciprocal of that is going to be 1 over 1, and opposite meaning opposite sign. So they are opposite reciprocals. So that means that, a little bigger, that line AB is perpendicular to line BC. So since my slopes are opposite reciprocals, that means that, therefore, segment AB is perpendicular to segment BC. All right, so if segment AB is perpendicular to BC, what is formed? A right angle is formed. Okay, so for your final answer, which I'm going to write down here, I'm going to say that AB is perpendicular to BC. That implies that the measurement of angle B equals 90 degrees. Therefore, triangle ABC is a right triangle. Okay, so this whole thing right here would be the answer I'd be looking for. Whoop. Right here. Okay. All right, let's try the next one. So think about what we did for this one as we get into the next one. So the next one says we want to prove that triangle ABC is an isosceles right triangle. So this one's going to be a little bit more work, but not too much. Let's first plot the points. So, oops, I forgot. Let me make my coordinate grid bigger. All right, so point A is at -2, -2. Here's point A. B is at 5, -1. And C is located at 1, 2. So we want to know, is this an isosceles right triangle? So we already know how to prove whether or not it's right. We did it above. So to prove that it's a right triangle, we have to calculate the slopes and look for opposite reciprocals. And then how are we going to prove that it's isosceles? What does it mean for a triangle to be isosceles? It means that at least two of the sides are congruent. Well, how am I going to prove whether or not CB and AC, or AC and AB, or AB and CB? How am I going to prove that at least two of the sides are congruent? I need to know the length of the sides. How am I going to calculate the length of the sides? I'm going to use distance formula, okay? So we're going to write triangle ABC is an isosceles right triangle if it has one right angle and two sides congruent. So you're going to check for perpendicular lines by calculating the slope of each line And then we're going to check for congruent sides by calculating the distance. All right, so over on this side, I'm going to find the slope of AB, the slope of BC, and the slope of AC. And I'm just going to do using counting rise over run on the coordinate grid. All right, and then I'm also going to find the distance from A to B, the distance from B to C, and the distance from A to C using distance formula. All right, so slope of A to B. So I have to rise 1 and run 1, 2, 3, 4, 5, 6, 7. So it's 1 over 7. For BC, I have to rise 1, 2, 3 and run 1, 2, 3, 4. So it's up 3 to the left 4. So it's negative 3/4. And for AC, you can start at A or C, it doesn't matter. I'm going to rise 1, 2, 3, 4 and run 1, 2, 3, both positive directions. So it's 4 over 3. Okay, so right away, I see that these are opposite reciprocals, right? Oop, I should have left more room. They're opposite reciprocals. So I know that BC is perpendicular to AC. If BC is perpendicular to AC, that means that there's a right angle at angle A. Where am I? Oh, ignore that. Then I guess I'm too low. The measurement, yeah, I'm too low. Okay, I'll write it out in a second. All right, and then the distance. So using the distance formula, differences of the x's squared plus the differences of the y squared, all under the radical. So differences of the x's, -2 minus 5, that's -7. -7 squared is 49. Now the y's, -2 minus -1, that's going to give you a -1. -1 squared is a 1. So that's going to be, let me erase a little bit here. That's going to be the square root of 50, which I actually don't need to simplify because I just need to know if any of them are the same. But I will go ahead and simplify because it's good practice. All right, 25 times 2, so it's 5√2. For BC, so from B to C, differences of the x's, 5 minus 1 is 4. 4 squared is 16. Differences of the y's, -1 minus 2, that's -3. -3 squared is 9. So 16 and 9 gives you 25. Square root of 25 is a 5. And A to C, so the distance, or the, difference of the x's, -2 minus 1, that's -3. -3 squared is 9. And then -2 minus 2, that's -2 plus a -2, which is a -4. -4 squared is 16. That's going to give you square root of 25, which gives you a 5. So these two are equal. Therefore, BC is congruent to AC. All right. So for your final answer, I'm going to say the measurement of angle C equals 90 degrees. BC is congruent to AC. Therefore, triangle ABC is an isosceles right triangle. Triangle. All right, so this would be the answer along with all your work, obviously, to support your answer. Okay. All right, guys, that is it for lesson 5.8. As I said, there are 2 examples in the notes that you are welcome to try on your own for extra practice. Feel free, if you're struggling with this, confused, not understanding the approach, jump into a 12th Cherry Google Meet with me. But otherwise, that wraps up chapter 5. See you back here for the next video lesson. Bye.